Hey guys, this is Terrence and welcome to the new episode of an Architect's P5.js notebook. And yeah, this is today's pattern. I call it square merge and arcs. The pattern looks like something subdivision, but actually it's the logic is something inverse. I created a lot of small cells at first, then merge some cells into bigger ones. Then we have this pattern. So let me bring up the sketches to show the process of creating this pattern. So the first step is we create a very generic square tessellation. I think all of you have knowledge of doing this basic pattern. And the second step is we can randomly choose a corner point, then merge some small cells into bigger ones. Here we have two standards. The first one is we merge 4 squares into a 2x2 larger square. The second standard is we can merge 9 squares into a 3x3, the largest square in our design. So this is called a square merging. But in the whole process, we need to avoid 3 kind of situations. The first one is intersection. If 2 larger squares intersect with each other, we abandon the merge. The second one is called the inclusion. Maybe we select the same point, but in the previous time we merged 4 squares into a larger one, but this time maybe we want to merge 9 squares into a 3x3 one. But it's basically a repetitive thing. I mean we don't, if we merge a square, if we already merge a square, we don't merge it again, so we will avoid merging any existing large squares. The last one is called out of boundary. That is, if the square is out of our boundary, out of our width and height limit, we will stop that merge. So these are 3 exceptions. Yeah, so I think this is the way we merge squares. And after we have squares, we will draw arcs. And because we have 3 kinds of squares, we have squares in 3 sizes, so we have 3 ways of creating arcs to ensure all the arcs connected with each other, just like this pattern. You can see the arcs are connected at both ends. So for the single length one, we just create arcs on the diagonal corners, but on the double length one, we will create arc on all 4 corners. Sorry. And for the largest condition, we not only create arcs on all 4 corners, we also create this kind of intermediate arcs diagonally. So I think this is the whole process of creating this pattern. And yeah, let's code it. And let me bring up this. Yeah, this is our editor. And I think, yeah, some setups. The first step is we need to create our canvas. So we can say create canvas with the size. We can do like 600, by 600. And we will set the background as black. Then we can run it. Yeah, I will put this canvas aside. Put this canvas and the code editor side by side. So we have our context. The first step is we need to create the generic generic square tessellation. So maybe we should define the size of each small squares. We can say a constant variable rectangle size equals to 60. And yeah, so we will divide this canvas into a 10 by 10 grid. So we also need let x number and y number, they represent the number of squares along the x-axis and y-axis. And here we should calculate them. We can say x number equals to the width of the canvas divided by rectangle size. and we should convert this value into an integer. And we do the same thing on the y number. We can say y number equals to integer height divided by rectangle size. So we have our x number, we have our y number. We can do our first function. And yeah, we can put some comments here. We can say step 1, we creating grade. And we define a new function called initialize recs. We initialize rectangles, and based we can create all the rectangles based on the rectangle size and the two numbers here. But this time we do something slightly different. Instead of store all the rectangles in the list, we will store rectangles in a dictionary, in a JavaScript dictionary. That will be easier for us to do some future processing like merge or like detection or creating arcs like that. So we create we declare another constant variable called rectangle dictionary. It's an empty dictionary, and so inside this initialize rectangle, we should loop over x number and y number. So we can say for let x equals to 0, x smaller or equals to x number, x plus plus, and then inside this loop we create another nested loop. We say let y equals to 0 if y smaller or equals to y number, y plus plus, and we have this nested loop. We can start put the index, put the key value and put the key value and put the coordinate value into this rectangle dictionary. So we can do rectangle dictionary with the key value. It should be, it should be a square bracket backtick. Yeah, this is backtick, and the first number is the first value should be x. Yeah, and with a comma, the second value should be y. So this is our key. We basically putting the new value and the new key into the rectangle dictionary, and this equals to rectangle size. Then we can try to save it and call the function here. We say initialize rectangles, and then maybe we can log the rectangle to check did we successfully created the rectangle dictionary. Save it and refresh it. Open the terminal. There must be something wrong on the line 2. Oh yeah, constant rectangle dictionary. Yes. Yeah, and you can see we have our dictionary here. The structure is like 0, 0. I prefer to bring up this sketch, and I will put these two things side by side to explain the structure of this dictionary. 0, 0 and 0, 1, 0, 2 is the index, or is the position of the upper left corner of each rectangle, while the 60 indicates the size of the square. So this is 0, 0 with the size 60, this 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, so on and so forth. So we have this rectangle dictionary or square dictionary. We should write a function to visualize them on our canvas. I prefer to increase the size of our canvas. Maybe I will do 720, make it wider, and I will remove this lock that will make my computer slow. Then we will create another function to visualize squares. So we can say function draw rectangles here, and inside this function we can do because because now we are using the dictionary, so we need to extract its key value and also its size. So we can say we should first extract both values I mentioned. So we should say object.entries. Entries, yeah. Our dictionary rectangle dict, and we have extract the entries. We should say for each. Then we can process the whole dictionary for each. We define the value name, variable name as item, and with the arrow function here. Then the first thing is we need to convert the key value, the x, y, the 0, 1, 0, 2, 0, 3 value, and convert them into the x position and the y position. That's our first steps. So I'd like to say let position equals to item with index 0. But this one is now stored as a list of strings. We need to extract both values again and convert them to integers. Yeah. So we should say we should first split the string into two values because we make the key value as a dictionary. So we should say split. We should say split here, split by this comma. Then we will get x and y respectively. And then when we have this, we should start convert them into integers. We can say let start x value equals to, maybe I want to convert the value type directly inside this position variable. I can say position equals to position.map d. For each d, convert that value into the integer d and save it. Yes, then maybe we can log this position value to see did we successfully convert all the string value into the integers. We can say draw rectangle, call the function in the draw function, run it. Oh, it's a lot of data inside here, but yeah, it's fine. We can see, yeah, we have two values for this kind of position variable. We have two values. We have 5 at first and 3 at second. That means in the 5th row and the 3rd column, and both value are integers. So basically we have what we want. And then we should find we should convert these indexes into the coordinates. So we should say let start x equals to position 0 multiplied by rectangle size. We do the same thing on the start y value equals to position with index 1 multiplied by rectangle size as well. And we have the coordinates value. We have we should still extract the size. So we should say size equals to position with the sorry, it's not position, it's item with index of 1. Then we have our size, and then we can, I think we can, what we can do, we can just draw the rectangles. Yeah, let me double check this code. Yes, we have size. So let's try to draw the rectangle. We can say no fill and the stroke as white. Stroke width could be 2, and then we draw the rectangle with the start. Sorry, it should be inside here. Start x, start y, start x, start y, and yeah, size and size. I think that works. Save it and run it. Yeah, we have our base grid. So we basically finish our first step. The second step is we could randomly pick a coordinate somewhere here or pick a position somewhere here, and to check is the position meet our merge conditions. Maybe we will set a random function to decide do we need to merge 4 squares or do we need to merge 9 squares. So this is randomly selected. The position is randomly selected, the length of size are randomly selected as well, and we have these 2 conditions. We will check these exceptions. If no exceptions arise, so we can just merge all the squares into a larger one. So this is the logic, and yeah, we can code it. We can see step 2 is merging squares SQL. Yeah, I have the right spell, I hope. Function, and the function we can define another function called merge, MERGE, merge rectangles. Inside here, we need first find 2 random values. The first one is the random position. The random position somewhere in the upper left corner of each rectangles. The second one is the size, the random size. Random size will only be two numbers, 2 or 3 as the size. The size units. So let's do I think let's first test it out. Let's say current key. Yeah, let's first extract those key values. So we can say keys, let keys equals to object dot keys. And the object we need to put here is the rectangle dictionary, and we will have all the keys. Now we have all the keys. We need to randomly select one of the key inside all the inside this tessellation. So we can say rand key equals to a random function. This is a P5.js function, randomly pick a value from the list. And yeah, we can put the keys list inside here. Then we can log the rand key here. But before we refresh this canvas, I want to add another random thing, which is the size of our larger square. So I prefer to say the size should be I call it span. New span equals to random, could be 2 or 4, because this value, the end value, is exclusive. So if we want to get a random value ranges from 2 to 3, we need to put 2 and 4 inside this random function. And at last, we should convert it into an integer value. So we can try to log the new span and random key value to see are we doing good in this small part. Refresh it. Oh sure, we should call the function here. Merge rects. Save it and run it. I think I should put a no loop here. So the canvas will only run once. Then we have 2 random values. The first one is the position, which is the first row. First row is here. This is the row 0, row 1, first row, and the second column is this one. And the new span of this cell should be 2. So the new larger rectangle looks like this. So we have our random value. And then what we should do is to merge these 4 cells. But before that, I prefer to, let me see what I can do. I should first check I should first check the out of boundary condition. So maybe this time I need to do the same thing here to find the index value and add 2 to see if that value is out of our boundary. So we can say our choice equals to, yeah, because we already have a random key here, so we can say choice equals to rand key first split the string into into a list. Then we will have two string value inside here. Yeah, then we should convert it into an integer, into integers. So we can say choice dot for each the data and the index here with an arrow function, and choice I equals to integer d. So we will have our new we will have our new position data here, and I can log it out to see the result. Yeah, so we basically convert the key value into two integers. This is the row index and this is the column index. Then next thing we need to check if this each of these value added this new span, if if the row at the span is still within the range of the x number and the x number, and if the y value at the span is still inside the x number, inside the y number range, if these two conditions passed, we can merge the cells. So we can say here like new span if choice 0 plus new span is smaller than the x number we defined here, and the choice 1 plus new span smaller is smaller than y number. Yes, if these two conditions fulfilled, and we can do the next step, but here I would do something inverse because I want to put this whole function into a while loop. Then we can keep subdividing the whole tessellation. So I will do something inverse, like if this two value, if the summation of these two values is larger than x number, which is out of boundary, and this combination is larger than y number, out of another boundary, we just continue it. So if we want to do this, we should wrap all these things so far into a while loop. So we can say while the iteration is smaller than, we should say while the current iteration ITR is smaller than total iteration, then we can do this. And inside here, I should update the current iteration immediately to avoid any kind of while loop, any kind of infinite while loop. So I should say current iteration plus equals to 1. And here I should define current iteration equals to 0. And here I want to put a parameter into this function, which is iteration. And by default, I want to set it as a very small number to avoid, just to test the function to avoid any kind of errors. So if this out of boundary condition happened, we just finish the current loop to pick another position and generate a new span. So we have this one, and yes, we continue, and yeah, as if we have this condition here, we can start to merge those squares. Yeah. So here we have if condition finished, and then we can say to be delete. We can put these four squares. Maybe we pick this one. We can put these 4 squares into a to be delete list. So we can declare another variable called to be delete in equals to an empty list, and also we will extract each of the site length value into another list. We call it check value equals to an empty list as well. So we will loop over all the subsquares inside this new larger square. Yeah, just assuming we will have this 4 square merge. So we can say for let I equals to 0 if I is smaller than new span and I plus plus. Inside here, we can say for let j equals to 0 and if j smaller than new span j plus plus. And we can start adding value. We can start adding value to the to be delete and this check value function. So we can say let index equals to index equals to plus I. Yeah, we can convert the new indexes into the keys and use the key to extract value from the from the rectangle dictionary. So I can we should do something reverse compared to this part. In this part, we basically extract keys and convert them into 2 integers. But here we convert integers into strings and use the string to extract the value from the rectangle dictionary. So we do backtick and say choice choice with index 0. So it should be variable here. Index 0 plus I, and this is the first one. The second one, oh, no space. Choice with index 1 plus j, but we should avoid a condition that if the I and j are both 0, that means they're located in our start point. So we don't want to remove our first rectangle because we want it extend. We just remove the rest of the rectangles. I think I should bring up this again to explain this problem. Like, if we want to merge these first 4 squares, when we are looping over these 4 squares, we want to avoid deleting this one because we want to keep the data of this one and change its size length to 2. So this is the logic. So we just preserve this one and delete these 3. So here we add another condition. We say if I plus j equals to 0, then we continue. And yeah, so we have our index. We say to be delete dot push idx, and we also need to extract the value extract the value at the index at the key here. I call it index, but it's actually a key at key here from the dictionary. Then we add the value, another value into another list called check values dot push rectangle dictionary, and with the key value of idx. So we have the to be delete list. We have a value list here. So this time we should check two things. If these two are intersect, that means maybe let's see how I can explain this. 1, 2, 3, 4. Yeah, maybe let me do this. Okay, let me move this rectangle to here. Sorry, and this one. Yeah, I should move this one to here, and this one to here. Okay, so assuming that in the previous iteration we already divided these, already merged these two small squares into a large one. So basically these four small squares are disappeared. And this time, if we want to merge these 9 squares into a larger one, into a 3x3 one, when we loop over all these small squares, we will find this one is disappeared. And the disappear or the disappear or it's not existed. If the value is not existed in the JavaScript dictionary, that will be called undefined. So when we loop over all these squares and check the value, check the dictionary and value of each square, if this one is not existed, it's removed by our is removed in our last iteration. This one will return an undefined value. And if we find this undefined value, that means these two squares might intersect. So we should stop merging this one. So this is the logic, and let me write a code here to say if check values include the undefined, undefined, and also in the check values, dot some values is check values dot some values. Yeah, some values is larger than, sorry, d here, an arrow function. D is larger than rectangle size. That means it's already subdivided. So if these two conditions return a true, we should I think we should just continue, just stop current iteration and go to the next one. And if all of these condition if all of these condition fulfill, if all of these check passed, we can just subdivide all the to be all the small rectangle, all the small squares in the to be delete list. So here we can say to be delete. Sorry, I think I should add an E here to make things clear. Maybe delete, and the to be delete list dot for each d, and d arrow function. And yeah, we should remove the values from the rectangle dictionary. So we should say delete rectangle dictionary with the key value of d, and then update the length value here. So we should say rectangle dictionary dot rand key equals to new span, and multiply by rectangle size, and I think we basically finished this merge rectangle function. Hope it works. Check values is not defined in line 58. Check val, yeah, check values, I should say check values. Run it, and include is not a function. Includes, it should be includes instead of include. It's JavaScript function, and you see we have our first merge here. Then what we need to do is just to increase the iteration. Then we will get more and more and more these merged squares. So if we increase it to 100, I think we can get more. But there is a limit, like if all the small squares are merged and some remainings line up like this, this part will not possible to merge into another square because they don't have four square combination. But this one, yeah, this one is possible, but these cells are impossible to merge again. So if we keep increasing the iteration, there will be a limit that creates just one that create the all merges or something. Yeah, sorry, I'm a little chaotic here, but I mean the iteration has a limit that if all the small squares are merged, no matter how many iterations you created, you increased, the pattern will not change anymore. So just after my test, I feel 150 is yeah, it's a better decision. That we still have some small squares here, but we still we will also have some merges, like the two the double length rectangle and the triple length square double length square and the triple length square here. English pronunciation. So I think, yeah, we have our rectangle here. Sorry, we have our merged squares here. Let's see what's the next step. It's create this create these arcs. So let's do this. And to draw these arcs, we need to create a new function. And yeah, I prefer to draw it instead of creating any other list. We just draw it. We don't create any other data. So we can say function. But yeah, a comment here to make the code slightly organized. So we should say visual. We can say visualize arcs. And here just say draw arcs. And yeah, and we will have three possibilities. The first one is for the single length one, we just draw the arcs diagonally. And the double length one, we need to draw the arc on all four corners. And for the triple length one, we also need to draw these intermediate arcs. And here we should think about the sequence, the layer sequence of drawing. If we draw these small arcs first, and then we draw these larger arcs, if we fill those arcs or fill these pies, the smaller one will be covered by the larger one. So our sequence is to draw the larger one first, then goes to the smaller ones. Okay, so I think we can start writing some code in this function, and we should do the similar thing here. A similar thing as the draw rectangle function. So we do object dot entries rectangle dictionary, and for each item arrow function and curly brackets, yeah, a semicolon. And inside here, let's first let me see. Yeah, let's first find the position and find the coordinates of four corners, because if we want to draw an arc, we need the specific position, or I mean specific coordinates. So we can do let position equals to item 0 dot split. It's almost, yeah, it's almost identical to the drawing rectangle one, but we can do it again here, comma, and position equals to position dot map d arrow function d0. Yes, and yeah, this is convert the key value to integers, and then we can say start x coordinate equals to position 0 plus the rectangle size. Here is start y value equals to position with index of 1. No, it should be multiplication, not plus. Multiply by rectangle size, and we have our coordinate of upper left corner of each small square. Then we need to find the size of each small squares, the size of each square. So we can say let size equals to item 1. This is the size of each square. Then we need to extract all 4 corner coordinates. So we should put all 4 corner coordinates into a list. So we say PTS equals to an empty list. It should be a 2D list with 4 points represents 4 corners. And the first one is for sure start x, start y. The second one is like I put the point in the sequence of in the sequence of clockwise. So this is the first point. The second point is start x plus plus size. Yeah. So start x plus size, and the y coordinate is start y. Make it 2 lines. And the third one is start x plus size, start y plus size. The last one is here, it is just start x and the start y plus size. So we do start x, start y plus size. And we have our points. The next thing is we need to we just focus on the triple length square at this time, because we should draw the larger arcs than the smaller one. The logic of drawing the larger these intermediate arcs. The logic of drawing these arcs are we randomly select these two corners, or these two corners, then use the corner as center point, use this length as the radius to draw an arc. So our method is gonna be we first to define which 2 corners to extract. So we can say let I equals to int. It's an integer of random with 0 to 2, that basically generates 2 integers. The first one is 0, the second one is 1. If we, let me bring up this again. I hope this will be more clear. And if we think about the index of these 4 corners, this is going to be 0, 1, 2, and 3. So think about this. If we pick this as 0, we set the step of 2. So we say the first point we want is 0 with 2 steps. The second point is going to be this one. It's going to be 0, 1, 2. Yeah, it's going to be 2. And if we randomly select this point with the 2 steps, we will have this point, this corner 1, and add 2 steps with the corner 3. So basically the first step, we just decide which corner we want to start, maybe 0, maybe 1, then we add 2 steps. We will get the diagonal corner. So let's keep doing. So as I just mentioned, we can define the step as 2. And yes, And I think we can just start drawing those larger arcs. So we just say if size large rectangle, yeah. Oh yeah, I think I forget something here. I should pick up. I should figure out is the current is the current rectangle or I mean is the current square we are working on is this the largest one? If it is, we draw the intermediate. We draw the intermediate arcs. If not, we just draw small arcs. So here we should write a we can write a line of code to check is it the largest square. So we say if the size is larger than 2 multiplied by a rectangle size at 0.1, so we will set it is a large. Now I should define another variable here. I should say by default the large square, large rectangle. This is easier. Large rectangle is false. It's not large rectangle. But if this line of code is true, we will have a large rectangle and set it as true. Yes, and yeah, this is just for checking. Is it the largest largest square, and if it is, we can just say while I is smaller than points dot length, length smaller than points dot length, and large rectangle is true, we start drawing the intermediate arcs. So we can say here we can remove the fill. We say no fill and the stroke color as white and the stroke weight as 2. Or here they call it stroke weight. And inside here we draw arcs. And the first value is the points x coordinate. We say point I coordinate x coordinates index is 0. The second input is the y value, and the third and fourth value are the radius along the two axes. So the first one is rectangle size multiplied by 3. The second one is also rectangle size multiplied by 3. And then the start angle should be pi divided by 2, it's 90 degree, and multiplied by I. The end angle is pi. Can I divide it into 2 lines? Yeah. Pi divided by 2 and multiplied by I plus 1. Then the mode is pi. We want to draw a pi shape. So we have this one. Let's test it out. Am I updating the value of I? Seems not. Yeah, so I should keep this in mind. I should always update the I value at the end of each loop, or it will stuck in the infinite loop. I plus equals to step and save it and call the function here. We can say draw what? Draw arcs. Yeah, draw arcs. Parenthesis, save it, and yeah, run it. And now you can see we have our intermediate, these intermediate arcs. The next thing is we just create the small arcs for all of the squares. So after finishing this, this intermediate curve, we can keep working on the small arcs. And below here, let me see what I can do is yeah, we say if the size, I mean, if the size of the square is larger than its basic size, I mean, it's larger than 1 unit of the length, we draw arcs on all 4 corners. Else, we just draw small arcs on the diagonal corners. So I can do this by if the size is larger than rectangle size plus 0.1. This is just for the how to say that? This is just for safe, because sometimes two float values might not equal because of the float value have many small digits at the end after the point. So yeah, I just do it for safe. And if the size is larger than rectangle size, we set the I value to 0 and we set the step to 1. So in this condition, we can just draw the arcs on all 4 corners. So we do while I smaller than points dot length. And yeah, this condition is enough. And I should keep in mind to update the I value. And here we can draw arc. And yeah, I think it's pretty similar here, but this time we just we can copy these 2 lines of code, paste it here, but this time instead of multiply the rectangle size by 3, we just keep the rectangle size unchanged. Save it and run the code, and I think we have this, but it seems there are some weird parts. Let's try to fix these problems. Where is the problem of this one? Let me see. Pi plus 2 palette. Not this one. Okay, let me just remove this while loop to check the current condition. Yeah, yes. Step 1, I plus equals to step. Yeah, it works very well on the triple length one. So let me see if the size is larger than and I smaller than this one. X coordinate, Y coordinate, start angle, end angle. Save it and run the code. Okay, I think I realized what's going on here. It's this value. Yeah, I wrongly put it as an I wrongly, how to say, I make a mistake here. I should convert d into an integer value. So yeah. So this is our pattern, and we can see all the arcs are connected with each other except these boundary ones. So yeah, this is today's pattern. And yeah, because we are using the dictionary and some data processing, I think this video is somewhat pretty complicated and convoluted. But yeah, this is the most efficient way I can come up with to create these patterns. So if you are not familiar with the dictionary or some arrow function, chain function, please check the Mozilla website. I will put the link down here. And yeah, that's it for today's video. I feel this is another long video. I always create long videos because I feel if we want to explain this, we will. If we want to explain and completely go through this process, this all processes, it it should be such a long time, so sorry for so many of my long videos, and thanks for watching. Have a nice day. Bye bye.